An exoplanet, or extrasolar planet, is a planet outside of our solar system that usually orbits another star in our galaxy. These planets come in a wide variety of sizes, from gas giants larger than Jupiter to small, rocky planets about as big as Earth or Mars. So far, scientists have categorized exoplanets into the following types: gas giant, Neptunian, super-Earth, and terrestrial. A gas giant is a giant planet composed mainly of hydrogen and helium. Gas giants are also called failed stars because they contain the same basic elements as a star. A Neptunian, or ice giant, is a giant planet composed mainly of elements heavier than hydrogen and helium, such as oxygen, carbon, nitrogen, and sulfur. A super-Earth is an extrasolar planet with a mass higher than Earth's. The term super-Earth refers only to the mass of the planet, and so does not imply anything about the surface conditions or habitability. A terrestrial planet, telluric planet, or rocky planet, is a planet that is composed primarily of silicate rocks or metals. There are 5 methods scientists commonly use to discover exoplanets. The radial velocity method measures these variations in the speed with which the star moves toward or away from Earth. An example being the variations in the radial velocity of the star with respect to Earth. The photometric method can determine the planet's radius. If a planet crosses or transits in front of its parent star's disk, then the observed visual brightness of the star drops by a small amount, depending on the relative sizes of the star and the planet. Planets orbiting far enough from stars to be resolved reflect very little starlight, so planets are detected through their thermal emission instead. It is easier to obtain images when the star system is relatively near to the Sun, and when the planet is especially large, considerably larger than Jupiter, widely separated from its parent star, and hot so that it emits intense infrared radiation. Images have then been made in the infrared, where the planet is brighter than it is at visible wavelengths. Gravitational microlensing occurs when the gravitational field of a star acts like a lens, magnifying the light of a distant background star. This effect occurs only when the two stars are almost exactly aligned. Lensing events are brief, lasting for weeks or days, as the two stars and Earth are all moving relative to each other. Astrometry consists of precisely measuring a star's position in the sky and observing how that position changes over time. Originally, this was done visually, with handwritten records. If a star has a planet, then the gravitational influence of the planet will cause the star itself to move in a tiny circular or elliptical orbit. Effectively, star and planet each orbit around their mutual center of mass. Thousands of exoplanets have been discovered and confirmed orbiting other stars. The first evidence of exoplanets dates to 1917, when van Manen identified the first polluted white dwarf. However, the first confirmed detection of an exoplanet would not come until the 1990s. The discovery of exoplanets grew in the years to follow with the launch of the Kepler Space Telescope. The Kepler mission was specifically designed to survey our region of the Milky Way galaxy to discover hundreds of Earth-size and smaller planets in or near the habitable zone, also called the Goldilocks zone, the area around a star where rocky planets could have liquid water on the surface, and determine the fraction of stars that might have such planets around them. NASA's Spitzer Space Telescope was used in the notable discovery of the TRAPPIST-1 system. In 2018, the Transiting Exoplanet Survey satellite TESS was launched as a successor to Kepler to discover exoplanets in orbit around the brightest dwarf stars, the most common star type in our galaxy. Through spectroscopy, reading light signatures for information, astronomers hope to learn more about planet atmospheres and the conditions of the planets themselves. The James Webb Space Telescope is a space telescope designed primarily to conduct infrared astronomy. Its greatly improved infrared resolution and sensitivity will allow it to view objects too old, distant, or faint for the Hubble Space Telescope. This is expected to enable a broad range of investigations across the fields of astronomy and cosmology, such as observations of first stars and the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. What's in an exoplanet name? An example of an exoplanet name is Kepler 16b, where Kepler is the name of the telescope that observed the system, 16 is the order in which the star was catalogued, and b is the closest planet to the star. If we were naming Earth as an exoplanet, it would be called Sun D. Sun is the name of our star, and Earth is the third planet, starting with B, Mercury. What type of songs do the planets sing? Neptune's